Hello, everybody. Welcome. This is chapter 15, Innate Immunity. This is part one of that chapter. We're going to cover the immune system in two chapters. Chapter 1, Innate Immunity, and then chapter 15, Innate Immunity, and then chapter 16, Adaptive Immunity. Let me give you this overview now. So in the box, we'll be combining the two things. And you've probably heard about some of this before in anatomy and physiology. Sometimes you will hear the immune system described in just these two parts, innate immunity and adaptive immunity. Innate, again, we're born with. Adaptive is what our immune systems can become as they get exposed to different microbes over time. Then you'll also hear the immune system sometimes described as far as 3 lines of defense. And first line of defense would be things like the skin. Second line of defense, there are certain cells that are kind of basic generalists that fight infection. And then the third line of defense are the really specific cells that go after the very tailored attack on microbes that have come in and that the immune system has learned. And why I'm going through this like this is because we use both of these ways of describing the immune system in our current textbook. And so putting it together, the innate immunity, this is covered in chapter 15, and you'll see references to first line of defense and second line of defense. And then in chapter 16, as though it were this entirely separate thing, we cover adaptive immunity, and you'll hear reference to this third line of defense. And why I'm putting it like this is so that there's no confusion. When you're in the chapter 16 and you get to the third line of defense, don't go back looking like, well, where's the first and second line of defense of adaptive? The adaptive immune system is the third line of defense. Okay. But for this week, we are going to be focused on innate immunity in chapter 15. What is this all about? It is this castle here is representing our bodies, and it is under siege. There are microbes that are trying to live off of us, live from the materials that we have acquired. And if you can think of it as stealing from us. Now, some of the microbes are mutualists, they're helping us, but some of them just are trying to get ahead, like all the viruses, and they're taking advantage of our resources. But we have some defenses, and that first line of defense, here we are with our soldiers here defending ourselves. The hordes trying to come in are here. The first line of defense is part of this innate immune system we're born with, represented here. These are the representing cells of our skin, and it's keeping all of these microbes at bay. We also have some cells. We have some mast cells, very importantly, that are playing a big part of the inflammatory response. And then we have some specific warrior cells, these macrophages, professional phagocytes, they're called. That means their specialty is to eat other cells. We have macrophages, it's your enormous cells that come from monocytes. The 5 different white blood cells, monocytes are one of them. And then they can develop into these macrophages in the tissues. Dendritic cells, we're going to talk about a little bit, in neutrophils. These are another one of the 5 kinds of white blood cells. Then in addition to these, we also have some so-called natural killer cells, which is one of the cooler names that cells get. And then more of the 5 kinds of white blood cells, basophils and eosinophils. In addition to these cells, we also have these systems of proteins that help us fight off infection. It complements the work of the individual cells. That's why it's called the complement system. We'll go through each of those in turn. So let's start with first line of defense, the skin. This is the so-called walls of the castle. The skin is composed of the two layers. Remember, this is an epithelial membrane, so it has a layer of epithelial cells and then a dermis, a layer of connective tissue. We have the epidermis on the outside. We have multiple layers, tightly packed cells. There's no space in between these cells. So it's hard for pathogens to get through. And we're constantly shedding cells, and that's one argument is that the evolutionary significance of shedding cells all the time is that it's hard for parasites to hold on to us because we keep dropping them off. Then there are epidermal dendritic cells. We do have cells, our own cells, that are kind of cruising around. I think of these like as mall cops. Like they can't do a huge amount of stuff, but they're on patrol and they can help to alert other cells of the system, alert the larger immune system that something's going on, that we're under attack. And here in the connective tissue layer underneath the dermis, there are collagen fibers that are pretty tough, and they keep the skin from tearing open very easily. Here's a scanning electron micrograph of some human skin. You can see the kind of flat epithelial cells, and then these, as they die, they flake off. And why they're dying is because the cells are so tightly packed, there's no room for blood vessels through here. You can, how can I say, the cells survive by getting oxygen and nutrients by diffusion through the blood vessels that are in the dermis. If you don't believe me about not having blood supply in the epidermis, have you ever gotten a paper cut that doesn't bleed? It hurts like the dickens, but it doesn't bleed. It's because you just cut through the epithelial layer, but you haven't actually gotten into the dermis and gotten into the blood supply. More role of the skin in innate immunity. There's some chemicals, perspiration itself. There's some salt, sodium chloride, that helps to protect us a little bit. There are some antimicrobial molecules whose job it is to fight off infections. The sebum itself, these are the sebaceous glands, the oil glands. These help moisturize the skin so it doesn't dry out too much, so it doesn't crack open. And it does help keep the pH of the skin a little bit lower, to inhibit some of the bacterial growth. All right, we also have a mucosal epithelial, so mucous membranes. Think of this as the inside skin. So you know how you have skin on the outside, but then we also have skin that's lining the inner cavities of the body. The mucous membrane lines all the body cavities that open to the outside, like the airway. I'll show you two distinct layers again. There's an epithelial layer, just like there was with the skin, a little bit different. The mucosal epithelium is a little bit wetter, it's a little bit thinner. They are living cells, they're tightly packed. Again, just like with the outer skin, there's shedding of these cells. But on top of that, we have now some goblet and ciliated columnar cells. So goblet cells producing mucus and ciliated columnar cells, the cilia moving that mucus along so we can cough it out, for example. And then once again, just like with the skin, there's the second layer, which is deep to the epithelium, and that is the connective tissue layer. And that's where the rich blood supply is. And so we have linings like this in the respiratory system, so lining all the sinuses, the mouth, the trachea, the digestive system, the esophagus going down through the stomach, all of the intestine. Here we have, even the lacrimal glands, exposure here, but we're fighting off infection in the eyes all the time. And the urogenital system, which is not pictured, but also has mucosal lining. we also have microbes living on us and living in our digestive system. And those microbes, many of them are helping us to fight off infection all the time. They compete with the potential pathogens because they're using up the resources in the area. So they're just kind of taking up space, ecologically speaking. And they make an environment that's unfavorable to other microbes. They also keep other pathogens from attaching to our cells. And in case it wasn't obvious, we do depend on some of these microbes. Some of them, for example, some of the microbes that live in the gut provide vitamins. Vitamin K is one example that's necessary for blood clotting, for example. And we get that from these microbes. And that is the end of part 1. And we will pick it up with part 2, and we're going to move on into the second line of defense. All right, see you over there.